Okay, we're going to continue to talk about the relationship that some special triangles have. So first we'll go with the isosceles triangle, which has two equal sides. So think of it as this. If this is a square, we know that each of these is the same side. So if you were to cut this in half, you could find this by using the Pythagorean theorem, because it's a right angle and we know one side. If we're just given one side of a million, well, this also would be a million. So you have two sides, and if you were to split this out, it would look like so. And it could look like any shape. I mean, it could look like this, for goodness. It could look like that. And if that's a right angle and then those two are the same, it's the same process. You only need to know one of those, okay? So that's the 45, 90, where it's a half of a square, okay? The other one we talked about first yesterday was an equilateral triangle, where we have all the same sides. They're all the same sides, whether it's W, W, and W. And if we create a perpendicular bisector, and our fancy word for just cutting it in half, and if it's perpendicular, that means we've created a 90-degree angle. And bisect means to split in half. So then if we see this as 2, and we also know that all these angles are 60 of a triangle, they must add to 180. So if there's 180 and you divide by 3 evenly, each is 60. So if you split that apart, we know that this is W, that's our 90. This was 60, because it's the half of the equilateral. Then this must be 150 from 180, which is 30. And just by knowing this one, we also know this one, because we cut it in half. That would be half W. So we have, once again, a right triangle and two sides. We could find the third side by using the Pythagorean theorem. Okay, that will be homework today. Just as a refresher on this stuff. Have a fantastic day.